Okay, pre-calculus 5.3, solving trigonometric equations with factoring. So just as a review, back in Algebra 2, if you were solving this equation and you're finding x, what would that be in regards to a graph? Well, to solve for x here, we would move the 8 over, and we're talking about factoring, so I'm going to go ahead and factor it. We have x squared minus 9x plus 8 equals 0. And I'm going to factor by guess and check. So this will be x and x. This sign right here, when it's positive, it tells me both are same signs. This sign right here will tell me which sign. And then if the second sign was negative, if we have a negative for the second sign, that would say different signs. But since it's positive, they're both going to be the same sign. So there we go. We have both minus signs. And then we need to think of two numbers that multiply together to give us 8, but add to give us that -9. So that would be 1 and 8. And so when I solve this equation, I'm going to have x minus 1 equals 0, x minus 8 equals 0, and I get the two answers of 1 and 8. So what does that have to do with the graph? So let me go ahead and graph that equation, x squared minus 9x plus 8. Oh, and this is where I left it from the last video. There we go. And we look at our x-intercepts, and we find out that the graph is equal to x when y is 0. And when we look at the equation, the x's are 1 and 8 when the y value would be 0 if we made this into an y equals graph. So what we're finding would be the x-intercepts. Now I go over that because while we're solving these crazy looking equations, you can use Desmos to kind of check your answers by looking at the x-intercepts, make sure that you're doing it right. All right, so we're going to think about factoring. We always want to look to see if there's a greatest common factor first. That's always the first step. So I'm looking at my two terms. Remember, terms are separated by plus or minus sign. And it looks like I have a greatest common factor of cosine squared x. So I'm going to pull out that greatest common factor. I'm going to be left with 3 minus sine x. Once it is in factored form, we can set each factor equal to 0. And we're going to solve for each factor. So cosine squared x equals 0. I'm going to square root both sides. If I square root, I have to do plus minus. But plus minus 0 is the exact same thing as just 0. So we don't have to worry about the plus minus for this one. Where is cosine 0? That would be at pi over 2 and at 3 pi over 2. The second part, we're going to solve for sine x. So maybe I'll move the sine x over. And then the question is, where is sine equal to 3? But when we graph sine, the highest and lowest that sine can be, or when we look at the circle, the highest and lowest that the y value can be is at 1 or -1. So it can never equal 3. So this is just a no solution. So we only have 2 answers total, and those answers would be at pi over 2 and 3 pi over 2. So I just want to show you how you can check your answers using the graph. We're going to graph 3 cosine squared x minus sine x cosine squared x. Desmos is a little funny about when you graph like trigonometric ratios multiplied together. You want to use parentheses for that. Otherwise, it doesn't like to work. And then let me fix my, excuse me, my graph again so we can look just from 0 to 2 pi. From 0 to 2 pi, we've got x-intercepts at pi over 2 and 3 pi over 2. So now I know that I've done it correctly. All right, the next one. I'm looking at the terms, and I have 3 terms. So first thing I'm going to do is decide, do we have a greatest common factor? And there is not something that is the same that can divide out of all 3 terms. So we do not have a greatest common factor. In 3 terms, these are the kind that are like x squared plus bx plus c, just like that equation that I did right up here in the warm-up. If having signs in there confuses you, you can do something called U substitution, where you can say, well, U is going to replace sine x. And you're going to rewrite this equation as wherever you see a sign, make it into a U. So here there's a sign, but it's squared. In the middle, we have 3 and then a sign. So I'm going to change that sign into a U. And then the last term is just a 2. And if I factor it this way, and I check my factoring, and let's see, that's a 1U and 2U, which adds up to be 3U. So I've checked my factoring and this factors correctly. Then what we do is we go back and put sine x back in where the u's were. So sine x plus 2 times sine x plus 1 equals 0. You do not have to use this u substitution. You could look at it and realize the sine x and sine x goes here. The 2 and the 1 go here. This is just an option if you were getting confused with all the words and letters. That's an option for you. Once you have it factored, you now have to set each factor equal to 0. And we're going to solve each factor. So right here, I've got sine x equals -2. And we just discussed over here, the smallest sign can be is -1. So this is no solution. And then right here, we've got sine x is equal to -1. Well, that's at 3 pi over 2. So my only answer is at 3 pi over 2. And when I say my only answer, I don't think I mentioned this, but we are looking from 0 to 2 pi. If I were talking about all the answers that ever were, then it would be 3 pi over 2. This is just a review from what I talked about the last video. Plus, to get to the next value, we would add 2 pi. Multiplied by any integer where n is an integer. Barely fit in there, sorry. So that would be all the solutions, but the directions are just saying to keep it between 0 and 2 pi. All right, the next one. In order to solve by factoring, it has to be set equal to 0. So we cannot start this one until it says equals 0. So I'm going to subtract cosine squared x from both sides. I will have 2 cosine to the 4th x minus 2 cosine squared x equals 0. Now I'm allowed to factor, and my first step of factoring, is there a greatest common factor? And I do see that we have a 2. Oh my gosh, why do we even have a 2 there? Never mind, we don't have a 2. We have a cosine squared x. So I'm going to pull out that cosine squared x using factoring. And left over, I have 2 cosine squared x minus 1. At this point, I can set each factor equal to 0. So cosine squared x equals 0, and 2 cosine squared x minus 1 equals 0. For cosine x equals 0, that's the same thing as, cosine squared x. When you square root it, it's still cosine equals 0. So that will be, and we just did that one right above it, that one will be at pi over 2 and 3 pi over 2. And then for this one, we're going to have to solve it. So I'm going to get cosine squared x equals, I'm going to add the 1 divided by 2, 1/2. But then I do have to square root and put in a plus minus. So I'm going to have cosine x is equal to plus minus. When I square root this, I have to rationalize it, and it ends up being square root of 2 over 2. Now that is all the pi over 4 values. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I wrote really big, so I'm running out of space. I'll just zoom in a little bit more. There we go. And our final answer is going to be all 6 of those, but in order. So we'll have x equals. So as I go around the circle, the first one I'm going to come to is that pi over 4, then pi over 2, then 3 pi over 4, and then down to 5 pi over 4. And then we hit 3 pi over 2, 7 pi over 4. Okay. And now we have 2 cosine squared x plus 3 cosine x plus 1. So you can do this with u substitution if you feel like you need it. 2u squared x, oh, no, let's try that again. 2u squared, I'm sorry, I should probably just say first, u is going to be cosine x. There we go. So then I'll do 2u squared plus 3u plus 1 equals 0. And so we'll factor that. We'll get u plus 1 and 2u plus 1. Just to double check that, this will be a u, this will be a 2u, those will add up to be 3u. So I've factored it correctly. Now I'm going to replace and put cosine x back in. Cosine x plus 1 and cosine x, 2 cosine x plus 1 equals 0. Set each factor equal to 0. And so I'll have cosine x is equal to -1. That only happens at pi. And then cosine x is equal to -1/2. And that's at 2 places. And they're in the second and third quadrant. Those would be at the 60 degrees reference, which is pi over 3. So we would have a 2 pi over 3 and a 4 pi over 3. We'll put all that together in order. So we'll have our first one is 2 pi over 3, then the pi, then the 4 pi over 3. All right, this next one, everybody just kind of gets tricked up by this one. You have to just be careful and look to find those plus and minus signs. So here is a minus sign, here's a plus sign, here's a minus sign. If I have 3 plus or minus signs, then I have 4 terms. If I have 3 plus or minus signs, I have 4 terms. And the way that we factor 4 terms would be to factor by grouping. Of course, I will always look for GCF first. So I look at all 4 of my terms, and they do not have any common factor that I could pull out. So now I'm going to group terms together that maybe could be factored. So I'm going to group together 4 cosine squared x secant x minus 3 secant x. You have to have a plus sign in between the two groups. So my plus sign, then I'll have a positive 8 cosine squared x minus 6 equals 0. So I put my groups in, and now we factor each group individually. So my first group, I'm going to check for a GCF, and we do have a GCF. We have secant. So I'm going to factor out that secant. I'm going to be left with 4 cosine squared x minus 3. And I'm going to see if I can factor this any further, which I cannot. So I've factored this group all the way. I'm going to look at my other group, and I'm going to first check for a greatest common factor. And we do have a greatest common factor. It's 2. So I'm going to first take out that greatest common factor. I'll be left with 4 cosine square x minus 3. That will not factor any further. So I have factored each group. Once I've factored each group, now we are looking at this equation and looking at this equation having 2 separate terms. So there is a term here and a term here. And oops, I'm sorry, I messed up the second one. It starts with a 2. There we go. Now what I'm going to do is I'm going to try to factor this binomial that is separated by 2 terms, this binomial. I'm going to factor, and we're going to start over with factoring. Again, GCF. Is there a greatest common factor between these 2? And there is. It's the 4 cosine squared x minus 3. So I'm going to undistribute that. I'm going to divide it out, and I'm going to put it in front. 4 cosine squared x minus 3. Once I divide that out, what's left over in each term? So we've got a secant x plus the 2, and that's all that's left over. So now we have factored this by grouping. We have 2 binomials separated by multiplication. So these are factors. Once it is factored, you can solve each factor by setting them equal to 0. So 4 cosine squared x minus 3 equals 0. So 4 cosine squared x equals 3. So cosine squared x equals 3/4. Square root both sides, plus minus. And I get cosine x equals plus minus square root 3/2. Over here, we've got secant x plus 2 equals 0. So secant x equals negative 2. I'm going to think about that being cosine x equals negative 1/2. And cosine is negative 1/2 in these 2 quadrants. Oh, I didn't even finish the other one. Cosine is negative 1/2 in these 2 quadrants. And that would be at 60 degrees, pi over 3. So for this one, we've got a 4 pi over 3 and a 5 pi over 3. And then for this first one, sorry, I forgot to, to do that last step. It's a plus minus, so it'll be in all 4 quadrants. And we'll have a reference angle of 30 degrees, which is a pi over 6. So we'll have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So we're going to combine all those answers. We're going to put them in order. Pi over 6, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and 11 pi over 6. For this example, again, we are solving by factoring. In order to solve by factoring, it has to say equals 0 or you can't do it. So the first thing I need to do is make this say equals 0. So I have my cosecant cubed x minus 2 cosecant squared x. Then I'm going to subtract my cosecant x. And then I'm going to add 2 to both sides. So now they've moved over to the other side. There are no like terms. So I have 4 terms. I have to do factor by grouping. In order to do factor by grouping, in the middle, I have to have a plus sign. So I'm going to change this to plus and negative. So when I do my groups, I'm going to have one group of cosecant cubed x minus 2 cosecant squared x plus, and then I will have negative cosecant x plus 2. So my 2 groups separated by addition. So this is not factored because it has addition. With the separate groups, we're going to go through the steps of factoring. So my first step of factoring, is there a GCF? Yes, cosecant squared. So I'm going to pull that out, cosecant squared x. I have left over cosecant x minus 2. Can I factor cosecant x minus 2 any further? No. So I'm done factoring this one. Plus. Now in my next one, I'm looking for a greatest common factor. And there really isn't a greatest common factor, but I notice that this number is negative. And usually if there's a negative, I tend to factor out a -1. So I'm going to factor out that -1. And when I factor that out, I get cosecant x minus 2. Now, I'm sure that when you learned this in the past, your teachers have told you that the parentheses have to be exactly the same. So that's another reason why I knew I had to factor out the negative number so that my signs would match. At this point, I now have a binomial separated by 1 plus sign. This is a big binomial. I am looking for a greatest common factor, something that is the same in both binomials, and that is cosecant x minus 2. So I'm going to factor that out, and I'm going to have my first factor as cosecant x minus 2. When I factor that out, it divides out, and what's left over is cosecant squared x minus 1. Now, cosecant x minus 2 cannot factor any further. However, cosecant squared x minus 1 can factor further. This is a difference of squares. And with the difference of squares, we have 2 parentheses, 1 plus, 1 minus, and we square root. We get cosecant squared x. I'm sorry, I just said square root and then I didn't do it. We square root, we get cosecant x and cosecant x. And then we square root the 1 and we get 1 and 1. And then you have factored by difference of squares. These these two binomials are called conjugates. Conjugates. We have 1 plus, 1 minus. And when we multiply those together by FOIL, the two middle terms cancel out. And that's how we get a difference of squares. All right, now I'm just going to set each factor equal to 0. I'm going to solve for each factor. For cosecant x equals 2, I might think of sine x is a half. And that's positive. And so it'll be both first and second quadrant at the 30 degrees. So we'll have pi over 6 and 5 pi over 6. For this one, we've got cosecant x equals -1. which is the same thing as sine equaling -1. So that would be down here at 3 pi over 2. And then cosecant x equals +1, which is the same thing as sine x equals +1. And that would be right up here at pi over 2. So we are going to put our answers in order. We'll start with pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. Okay, if you have any questions about factoring or solving by factoring using trigonometry, don't hesitate to ask. You have worksheet 2 to go with this one.